Hello, hello everyone, Mr. Cruze here with another review video for you. This time, the Trigonometry Chapter 5 test review. Alright, I want to start off this video by saying that if you happen to have any questions on anything that you're doing on the review, I will be back at school in the morning. I'll be there at 6, but I think the earliest you can get in is at 6:30. So if you are struggling with these topics, if you didn't do so well in our last quiz, please come in for help. Alright, I will be there. I expect to see you. Alright? Another thing I want to point out about this video, I will not be doing every problem on the review. Okay? I think A, that'll take too long, and B, you've got the answer key right in front of you, and C, all I really need to do, I think, is one example of each type of problem. Alright? So you'll see as we go along, I'm not going to do all 14 problems, but I will do one of each type. Alright? So let's get into it. Number one, and again, if you're following along on the worksheet, should be... Hang on. There we go. Finally got it. Number one on your worksheet's right there. Suppose triangle ABC is a right triangle. Right triangle being a key thing. A and B are the acute angles. We're going to try to solve the triangle, alright? So I'm just going to draw a picture, just a basic plain Jane picture. They said the A and B were the acute angles. So this is A, this is B. That means C is the right angle. Alright? They tell me A, the side across from angle A, is 2, and the side across from angle B is 7. My job is to figure out, well, first off, what are angle A and angle B? What are their measures? And also, how long is side C? Right? We need to figure that out. So we've got a couple choices here. You can really do whatever you prefer. I'm going to start with the angles. So if I want to find angle A, I need to use the two sides that I'm given. Well, I notice that 2 is opposite of angle A, whereas 7 is adjacent. Opposite and adjacent, that's tangent. So I'm going to say tangent of A equals 2 over 7. And then if I want to figure out what that is, I just take the inverse tangent. Alright? So you can literally do this on your calculator. You just have to make sure that you are in degree mode, of course. So inverse tangent 2 over 7. And the measure of angle A is 15 point, we'll go 2 places, 95 degrees. So 15.95 degrees. Now, how do I get angle B? Well, that's actually pretty simple. Since this is a right triangle, I know that the two acute angles have to be complementary. They have to add up to 90 degrees. So you can take 90 minus 15.95. You could take 180 minus both of these angles, but since this first one's already 90, might as well and just go ahead and subtract it from 90. Anyway, you get 74.05 degrees. Another way you could do get B is you could do tangent of B equals 7 over 2. And if you type that in your calculator, you do figure out it is 74.05 as well. Alright, now how do I find side C? Well, you can actually use trig with one of these two angles. You can do that, you'll get an answer, but since we rounded to get these, our answer will probably be even more rounded. So I'm going to actually do something else with right triangles. Since I have two sides, I'm going to use Pythagorean Theorem, right? A squared plus B squared equals C squared. So let's see, 49 plus 4 equals C squared, so 53 is C squared. So C will equal radical 53, but we're doing decimals here, so C equals 7.28. Easy enough, right? So we just solved that right triangle. I think right triangle problems are the easiest problems. That's probably why in geometry class we extensively studied them. Okay? Alright, number 7, this is a word problem. The measurement of the angle of depression of an aircraft carrier from a plane 1,000 feet above the water is 63 degrees 18 minutes. How far is the plane from the carrier? Alright, so I'm going to draw a picture here. So somewhere here is a little aircraft carrier, right? We got a little boat. I know it's not really an aircraft carrier, but we'll pretend it is. And here's our little plane, right? Flying towards it. Awful picture, but that's fine. The plane is 1,000 feet above the water. And it says it's looking at an angle of depression of 63 degrees 18 minutes. The mistake most people do is they want to put 63 degrees 18 minutes right there, but that's not the angle of depression. Angle of depression is, didn't mean to erase my whole picture there. Angle of depression is the angle that the plane would look down. So this is 63 degrees 18 minutes. Which, by the way, is the same angle that someone on the boat would look up towards the plane. Okay, those two are parallel, they're alternate interior angles. You could use geometry there. Once you know that, we can actually figure out the distance from the plane Oops, sorry, wrong distance. We can actually figure out the distance from the plane to the boat, okay? If they said horizontal distance, it would be this, but they said just distance to the boat, so that would be the hypotenuse, all right? Well, 1,000 feet is the opposite. X is the hypotenuse, since this is a right triangle. So I'm going to use sine. Sine of 63 degrees, 18 minutes equals 1,000 over x. One cool trick with proportions, I can actually switch what's on the top of one side with what's on the bottom of another. That'll get my x out of the denominator, and then all I have to do is type that in my calculator. Okay? So, x is going to equal 1,000 divided by the sine of 63 degrees, 18 minutes. And you get roughly 1,119.36 roughly feet. Alright, again, these story problems, don't freak out about them. Just draw a picture. It's going to be triangles. Alright. Number 9. This one's kind of interesting. I believe they ask us how many possible triangles could there be, and they ask us to find them if there are any. Alright, so solve them. So I'm going to draw myself a quick picture. This time I don't know it's a right triangle. It's just a plain old triangle. They tell me angle A is 25 degrees. A, the side across from angle A, is 125. And B, the side across from angle B, is 150. You'll notice this is a side angle case. This is the bad case, right? The one that could have 0, 1, or 2. I notice that the side across from the angle given is shorter than the adjacent side, which means this could either be 0 triangles, 1 triangle, or 2 triangles. We're going to have to figure it out using law of cosines. Starting with the side across from the angle we're given. So we're trying to find C, right? So 125 squared equals 150 squared plus C squared minus 2 times 150 times C times the cosine of the angle we started with. Alright. I'm going to do some rearranging here. 125 squared, by the way, is 15,625. 150 squared is positive 22,500. I'm going to put the C squared up front. 2 times 150 is 300. Cosine 25, and then there'll be a C there. Alright. Last but not least, subtract the 15,625, so you get C squared minus 300 cosine 25C. At least this will be a positive answer. 6875. Alright. And this is a quadratic. You'll notice it's not the prettiest quadratic you've ever seen, but you can actually still solve it, right? So C equals negative B, so that'd be 300 cosine 25 plus or minus radical B squared, which is negative 300 cosine 25 squared, minus 4AC all over 2A. Alright. For the sake of time, this comes out to be 271.89. That's the first part of the decimal. Plus or minus, once you do all that and take the square root, you should get 215.47 all over 2. Alright, so it looks like there could be two possible outcomes here, right? 271.89 minus 215.47 divided by 2. And you should get 28.21, or the other option is, what happens if I add 215.47? Well, it turns, and then divide by 2. It turns out you could get two possible answers for C, which means there's two triangles here. One where the side C is 28.21, and one where it's 243.68. All right, and that will create two different angle B's and two different angle C's. Meanwhile, everything else will still stay the same. All right. So we're gonna have to actually figure out both of these. Question is, how do we do that? Right. So we're gonna have to add another page here. What if C is 28.21? All right. So let's pretend C is 28.21. Now I'm gonna find angle B. All right. B started with 150, right? So 150 squared equals the other side, 125 squared plus 28.21 squared minus 2 times 125 times 28.21 cosine B. All right. If I want to find B, and I rearrange this, it's going to be the inverse cosine of 150 squared minus 125 squared minus 28.21 squared all over negative 2 times 125 times 28.21. Okay? If you type all this in your calculator, you answer right away. You get angle B is 149.54 degrees. All right? So 129.54 degrees. And then if I want measure of angle C, well, I know the angles in a triangle have to add up to 180, so take 180 minus 129.54 minus the 25 we already know about, and that makes angle C 25.46. All right, so that's one of the possible triangles. Now let's get the second one real quick. Again, we're going to start with B, but this time, what if C is not 28.21? What if it's 243.68? Well, obviously that makes it the biggest side, so this angle should be much bigger than it was before, right? So again, B is going to be the inverse cosine of 150 squared minus 125 squared minus 243.68 squared all over negative 2 times 125 times 243.68. Okay? If you type that all in your calculator, you'll get the answer, which should be 30.47 degrees. All right. When I said it was the biggest angle, I meant C is going to be the biggest angle, right? 30.47 degrees. And then once again, you're going to take 180 minus 30.47 minus 25, and you get angle C to be 124.53 degrees. So there's your two possible triangles, okay? I think these are the hardest ones right there. By the way, if whatever you get under your square root sign comes out to be negative, then you'll have no triangles. You won't be able to make a triangle at all. So just be careful with that. All right, last couple. Let's see if I can go through this in a couple minutes. Once again, solving this triangle. So A, B, and C. A is 51 degrees, B is 40, C is 45. This is a side angle side type problem. So I need to find side A, I need to find the measure of angle B, I need to find the measure of angle C. Well, side angle side, I can use law of cosines to get side A pretty easy, right? A squared equals 45 squared plus 40 squared minus 2 times 45 times 40 times the cosine of 51 degrees. You can actually, believe it or not, type all this in your calculator. The only thing I would do is I would put parentheses around that whole part right there. That way you'll get it nice and neat. When you do, you get A squared equals 1359.44, blah, blah, blah. Anyway, take the square root of that, and you get 86. So A is 36.87. And then we can figure out one of the angles. And again, I prefer to use law of cosines because then you don't mess anything up, right? So let's find the measure of angle B. So I'm going to have to start with 40 if I do that. Equals 45 squared plus 36.87 squared minus 2 times all that. Again, the more you get used to it, the better off you are. So eventually B equals the inverse cosine of 40 squared minus 45 squared minus 36.87 squared all over negative 2 times 45 times 36.87. Alright, type that all. When you do, I get B to be 57.47 degrees. Okay. And the measure of angle C, you just take 180 minus the angle you already knew, 51, minus this new angle of 57.47. Obviously, C has the largest side across from it, so C has to be the biggest angle. And it is at 71.53 degrees. Alright. Alright, that's pretty much one of everything. The only thing I was going to do, number 13, to help you, but our video is running a little short. All you have to do for area is just use 1/2 AB sine C, or, depending on which sides you use, you could use BC sine A, or you could use, AC sine B. It's your choice. But notice, you'll need an angle. We only have sides here. So you'll have to use some of what we did up here, namely law of cosines, to figure out one of the angles, and then you plug it into that formula with the appropriate sides there. Okay? This test should be easy. If you need help, please tweet me or email me, alright? Good luck, and I hope to see you tomorrow.